Hello friends, continuing with the topic of logic circuits in the chapter of semiconductor and electronic devices. Today we come to its second part, logic circuits part 2. In this part we will study about analog signal, digital signal and logic gates. Now first we take up analog signal. What is an analog signal? Let us define. A time varying voltage or current having continuous values is defined as analog signal. I repeat, a time varying voltage or current having continuous values is defined as analog signal. Look at this diagram. This diagram represents an analog signal where we plot V or I along positive y-axis and time along positive x-axis. Now this graph is the graph of analog signal. It's a two peaks, plus side and minus side, and the values are continuous from 0 to 2 pi. Now second, digital signal. Let us define digital signal. A time varying voltage or current having two discrete values 0 or 1 is defined as digital signal. I repeat, a time varying voltage or current having two discrete values either 0 or 1 is defined as digital signal. Look at this diagram. In this diagram we take up time along positive x-axis and voltage or current along y-axis. Now two values, discrete values are 0 and 1. Now third, logic gates. What is a logic gate? Let us try to understand it. A logic gate is a digital circuit that follows certain logical relationships between input and output voltage or current in the circuit. It is defined as a logic gate. I repeat, a logic gate is a digital circuit that follows certain logical relationships between input and output voltage or current in the circuit. It is defined as logic gate. Now specific meanings of 0 and 1. When we say 0, what does it mean? When we say 1, what does it mean? So look in this table. Here we have shown 0 and 1. In the first case, 0 means low, 1 means high. In the second case, 0 means absent, 1 means present. In the third case, 0 means off, 1 means on. Fourth case, 0 means no, 1 means yes. So these are the meanings we take up in different situations according to our requirements. 0 means low, absent, off, no. And 1 means high, present, on, yes. Okay. 3 primary gates. We come across 3 primary gates: OR gate, AND gate and NOT gate. We take up one by one. First we take up OR gate. So first point, circuit. This is the circuit as shown here. Second, realization. An OR gate can be realized by using two diodes, one resistance and one battery as per circuit shown above. Okay. So this is the circuit of OR gate. 3. Number of inputs. Number of inputs of OR gate is 2. It can be 3, it can be 4, but here we are to deal with a 2 input OR gate. So number of inputs are 2. Fourth, number of possible operations. Number of possible operations, the formula is the base of binary number system is 2 and raised to power the number of inputs. So base of binary number system is 2, and since there are 2 inputs, therefore its power 2 is raised to number of inputs, that is 2 raised to power 2, which is equal to 4. That is 0 0 0 1 1 0 1 1. So either A can be 0, B can be 0, or A can be 0, B can be 1, or A can be 1, B can be 0, or A can be 1, B can be 1. So these are 4 possible operations which are possible with 2 input OR gate. Now fifth, logic symbol. This is a logic symbol for OR gate. Wherever you see such diagram, immediately you assume that it is an OR gate. Okay. Sixth, function. Now function of OR gate we will learn in 4 steps: A, B, C and D. First we take up A. When A and B both are connected to ground, both diodes D1 and D2 have no bias and do not conduct. No current flows through R. There is no output. Hence, when A is 0, B is 0, Y is 0. Okay. Now B. Second step. When A is connected to ground and B is connected to positive of battery B dash, diodes D1 have no bias and does not conduct, but D2 is forward biased and conducts. Current flows through R. Output is available between Y and ground, that is across R. Hence, when A is 0, B is 1, Y is 1. Now third step, C. When A is connected to positive of battery B dash and B is connected to ground, diode D2 is reverse biased and does not conduct, but diode D1 is forward biased and conducts. Current flows through R and output is available between Y and ground, that is across R. Hence, when A is 1, B is 0, Y is 1. Okay. This is how we develop truth table. Now we have to look into fourth step also. Let us look at next slide. Now fourth step, D. When A and B both are connected to positive of battery B dash, both diodes are forward biased and both conducts. Now double current flow through R. Output is available between Y and ground, that is across R, and it is more than previous cases. Hence, when A is 1, B is 1, Y is 1 0. 1 plus 1 is 1 0, and for presence we write 1, we don't write 0 here. output is 2 times high, that is high and is represented by 1 only. 1 0 is binary of 2, 1 plus 1 is 2, so 2 we write in binary system of numbers as 1 0, so 1 0 means high we represent by 1. Okay, this is how we explain the function of OR gate. 7th, truth table. Truth table of OR gate is as shown here, that is A and B are 2 inputs and Y is output. When A is 0, B is 0, Y is 0. When A is 0, B is 1, Y is 1. When A is 1, B is 0, Y is 1. When A is 1, B is 1, Y is 1. This is how we write the truth table of OR gate. 8th, Boolean expression. Input A or input B is equal to output Y, or A plus B is equal to Y, that is input A plus input B is equal to output Y. Now let us look at the table. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is equal to 1 0, which is 2. 1 plus 1 in decimal is 2. So here in binary 1 plus 1 is 1 0. So for high we write 1 only. Okay. 9th, input and output waveforms. How we draw input and output waveforms? Here is input A, and in the table we have 0 0 1 1. So here in the waveform we develop 0 0 1 1. Now this is input B, and in the table input B is 0 1 0 1, and here we have 0 1 0 1. Now this is output Y, and in the table output Y is 0 1 1 1, and here we have 0 1 1 1. This is how we draw the input and output waveforms of OR gate. You must be able to recognize from the truth table which kind of gate it is. Also you must be able to recognize the waveform for a particular gate. That is the skill needed here to understand about logic gates. And we have seen that the 9 steps we have followed for explanation of the OR gate, and for every gate we will follow these 9 steps. If you understand OR gate properly, then you follow these 9 steps for every gate, and it will become easier for you to explain other gates. Thank you so much. Next time we will take up AND gate. Till then, goodbye and good luck to you.